Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and we will try to solve it together. So today we have a medium problem which is actually medium, not so difficult and not so easy also. So let's see the problem statement which is very simple. It is given that an integer array nums is given and you need to return the maximum possible sum of elements of the array such that it is divisible by 3. Okay, so you need to pick some elements of this array and tell me whether it is divisible by 3 or not. Okay, so what can you do for this? You see the length is something like 44, so you need to think in O of n or O of n log n or something like that. You cannot go to O of n square or anything greater than that. So yeah, how should you approach this problem? So you see whatever is told to you, try to visualize is that you will be given some elements and you need to pick only few elements of them in the array. So let's say you are picking these elements and you need to add all of them. The sum of the elements which you pick should be if you do a modulo 3, it should be equal to 0. It simply means that it should be divisible by 3. Okay, and you need to make the largest possible sum for that. Okay, so how many categories do you think? So if you take one number, let's say this array is some ARR. Okay, so let's say if you take a number ARR of I and if you try to divide this by 3, how many types of remainder can you get? So you can get only 0, 1 and 2, right? So you see in your answer, let's say you have a total answer variable initialized to 0. One thing which you can definitely do is that iterate through this array and add everything to your answer which is giving a remainder of 0. So let's say some 6 is there anywhere and let's say some 12 is there which are divisible by 3. You can keep adding them to your answer and the result you will get will also be divisible by 3. Okay, so I hope you get what I'm trying to say. So easily this case is resolved. Okay, so there will be no problem with this case. Now what is the case when these array elements are divisible by 1? I mean if you divide them by 3, the remainder is 1. Okay, so what will happen to those? Okay, so let's say take some example. Let's say you have 4. It is one number which you divide by 3, it gives a remainder of 1. Okay, and let's say you have 13. Okay, so it is also a number, if you divide by 3 you get a remainder of 1. And let's say another number which is what can you say about this number is that 7. So this is also one of those numbers belonging to this category which on divided by 3 gives them a remainder of 1. Okay, so what happens basically is that if you try to add these three numbers 4 plus 13 plus 7, so what you will get is 24 which is divisible by 3. So basically what happened, you got a remainder of 1 when divided by 3 with this remainder of 1 with this remainder of 1. So as you add these numbers, the extra values which are not being divisible, they also get added up to form 3, right? And this number is divisible by 3, so the whole addition is also divisible by 3. So if you know modular arithmetic, I can tell you something like this. So 4 is congruent to 1 modulo 3, it means that it leaves a remainder of 1 when you divide it by 3. Okay, so 13 is also the same. Okay, so what happens is that you can simply add these two numbers. Okay, so you can definitely say that 17 congruent to modulo 3. Okay, so if you see, if you divide 17 by mod 3, you get 2, right? Because the remainder is 2. This tells me the remainder. This is the thing which is telling me the remainder. So that's how modular arithmetic works. If you don't know, just try to understand. Okay, so and you see, you also have 7 congruent 1 modulo 3. You can choose to add these also, these two elements also. You will get 24 congruent 3 mod 3, and anything congruent 3 mod 3 is 0. It is equivalent to saying that 24 is congruent to 0 mod 3. So it means that 24 leaves the remainder of 0 when divided by 3. So that's how with modular arithmetic also you can say, and with visual proofs also you can say that these elements can be divisible by 3. Now you tell me, you have, let's say you divide, and same for you see, you can take for 2 also and check it in that way. The same thing you do with 2. One thing you try to realize when you do is that, let's say you have all the numbers, right? You try to divide them in 3 groups. Okay, 3 groups you try to divide them. The first groups leaves the remainder of 0 when divided by 3. Second groups leaves the remainder of 1, and this leaves. So we have already calculated our possibilities. When it leaves a remainder of 0, we will simply add all of those numbers. Okay. So when it leaves a remainder of 3, we need to subtract few numbers, right? So it may be possible that the addition of all these numbers which are there, it is giving currently a remainder of 1 or a remainder of 2. If it gives a remainder of 1, you can easily understand that we need to remove just one element, because all of them individually gives the remainder of 1 when divided by 3, right? So this if this is the case, that if you add all of these elements and modulo 3 is giving 1, you just need to remove one element. Okay, and then the whole additions will be divisible by 3. And definitely if you are removing something, if you want the maximum sum, remove the minimum one. Okay, and you see, or if it is a remainder giving you a 2, if you add all of this and it's giving a remainder of 2, it means that you need to remove 2 elements, and definitely after this the sum will be divisible by 3. So what will you remove? You will remove definitely the minimum one and the second minimum one. Okay, these two elements you will choose to remove to get the maximum sum. And so let's say answer has all of these sums, and then you add the remaining after removing one element, which is minimum or minimum plus second minimum. You add the remaining elements into your total answer which you have in your variable. Okay, and if you try to think of this case also, you can think it in this way only. Okay, there will be only two cases: either you have to remove one element or you have to remove two elements, right? So since individually each of them gives a remainder of 2, okay, so if the whole addition of all those elements into gives a remainder of 2, then you just need to remove one element, and that will be the minimum element. And if it is possible that it is giving a remainder of 1, okay, then what will happen? Basically you need to remove two elements. So what will happen if you remove two elements? You see, each element is giving a remainder of 2, so two elements will give a remainder of 2 plus 2, 4. But this is equivalent to saying that it gives the remainder of 1. So in that case, minimum plus second minimum element, two elements you need to remove. Okay, so I hope you try to do little bit of pen and paper. I hope you will also understand that what I'm exactly trying to say. So there exists only some possibility, and you may be removing 0 elements, right? That is your always priority is there, that you do not remove any elements, and you might be good to go with that. Okay, so you have only, you see, if you see, you have only 3 cases for this and 3 cases for this, so total 9 cases you have. So you can use a simple loop, 3 into 3, to check how many elements I am trying to remove from each of them, and try to calculate your answer and maximize your total answer, right? Maximize your total answer. So let's see, try to solve this. Okay, and I will also explain when I do the coding. Things will be very simple for you. Okay, so let's see. First I will try to separate all the elements into 3 containers. So let's call it 3 vectors only. So we will have n at first definitely, and let's have a vector of vectors. Okay, vector of vector int, and we call it v, right? And it has 3 lengths. Okay, so what will you have initially is that for every element in nums you can go through, and what you can do is that v of nums of I mod 3. So basically if it is 0, then it will go to the first element dot push back. So each of them is a vector, right? So push back nums of I. So I hope you do understand what I'm trying to say. There are 3 vectors here. Okay, the first vector gives you the value when it is perfectly divisible, that is the remainder is 0, then the second vector gives you when the remainder is 1, the third vector gives you when the remainder is 2. So similarly, this is that only, this will automatically handle everything. That is, when it gives the modulo 3 equals to 0, then it will push back only that particular vector. Okay, I hope you do understand. There is no difficulty in this. Okay, this much is very simple. So what you try to do next is that you create some answer. So what you can do at first is that in your answer, final answer which you will return, okay, you can simply add all the elements which is giving a remainder of 0. So uh, what you can do is that you can go through all the elements v of 0 dot size. You can go through all the elements of this and add everything to your answer, right? V of uh, 0 and I. So I hope this much is simple. And let's say you have some sum b and sum c. We will use them later. So these are the values. So basically sum b. So I am calling these sets something like this. Let's say I am calling this set to be a, and this set is b, and this set is c. So b is when it gives a remainder of 1, c is when it gives the remainder of 2, a is when it gives the remainder of 0. So a we do not need to calculate, that is nothing but an answer. The sum b and sum c we also just calculate uh, when it gives the remainder of 1 and 2 respectively. So you see, you can have this something like this, sum b and v of 1. Okay, you have this 2 and this 2, sum c. Okay, so I hope you do get what I'm trying to do. And right now what you can do is that, see, we need the minimum and the second minimum element, so we need to calculate that, right? So yeah, I can write a function. See, I need to do them twice for the first set and the second set also, so I can write a function for that. So uh, let's say I have some variables int uh, vector1. Okay, for the vector1, what is the minimum element? Okay, this is denoted by this. For the vector2, so vector1 simply means v of 1, right? Vector1 simply means v of 1. So remember that. Minimum2 means the second most minimum element. Second minimum element. I can write it in this way. And for 2 also, I can do the same thing, right? I hope you do understand uh, what I'm trying to do. Okay. So after you've done with this, you can write a function which will actually go through them and fill the values, right? So you can call a function which will be a void function, but it will take first this v1 min, uh, v1 min 2 also, and the vector v1. Okay, and yeah, for same for 2 it can do. And so it will do nothing but take this vector and calculate its minimum and second minimum value and store in them in these two variables. Okay, yeah, that will not be difficult, and you can do it, I guess. It will be a simple void function, and function I can write, uh, let's say this will be address minimum int address minimum 2, and you have another vector which is simple vector. Okay, so yeah, you can calculate the minimum and second minimum element. These, since these take the addresses, it already has been loaded with int max values. You do not need to do anything, you can just simply start iterating. So you can have this v dot size, go through all the elements initially and just check that if this v of I, if any element is less than my minimum element, then we got a new minima value, right? So we can update our minimum to something like v of I, but at the same time our second minimum value will be now minimum, right? So I hope you do get it. Yeah, so and else if there is another criteria that what if this is not true, vi is not less than minimum but vi is less than the second minimum value, then in that case you simply update your second minimum value. Okay, you simply update your min to value vi. So yeah, that's what you can take the address in this case also, and since we are modifying in the address values only, so there will be no problem, I guess. So yeah, that's all. I just updated my maximum and second maximum values. What I can do is that now I can iterate, have an for loop. See, I can remove 0 element, 1 element or 2 elements, right? I hope you understood this logic. So which combination is giving me the best result, I will take that. Okay, so let's say I have B. From the set B I can remove 0 elements or I can keep removing 2 elements. Okay, from set C I can also remove 0 elements or I can keep removing elements set. Okay, so what can you do for such a case? And you see, if one check you can do is that if okay, so we will do that later. So what is the thing now is that if you have to exclude one element, so let's keep this sum. We had the sum b and sum c, right? So let's have them in a different variable. So what we are trying to do right now here is that if b is 0, b is 1, so if we need to exclude one element, which is the element we will choose to exclude? It will be nothing but our minimum element from the vector 1. So from the vector 1 select the minimum element and exclude that. And if b is equals to 2, it means that you are excluding two elements, so you can simply from minimum 1 and minimum 2 you can choose to just exclude. Okay, so minimum 1 and v1 minimum 2 you can choose to exclude. Same things you can do for c, right? So for c you can do this, and sum c you can choose to write these vectors in this way, v2 and v2. Okay, so you are having it in this way, and what you can do right now is that if this sum b plus sum c is divisible by 3, so see, sum a, which the set a, every element was divisible by 3, so we added all of them to our answer, right? But now we will add our only those elements to our answer in which, let's say, this sum we are trying to maximize this value, and if this sum b plus sum c is actually if you modulo 3 equal to 0, then only we will add, right? Because everything in set A is already 0 equal to 0. Now we want to ensure that whatever we take from B and C, both of them addition should be equal to 0. And if this happens, I will try to maximize this dummy sum. Okay, I will try to maximize this dummy sum. So and at the end I will choose to return my answer plus sum. This is only my final answer because this contains the set from A. Okay, because set A has all the values divisible by 3 only, and this sum has the sum where B plus C is divisible by 3. So the whole thing, answer plus sum, will be divisible by 3. So I hope you do get it, and this will be nothing but sum B plus sum C. Now one thing is there is that, see, this is int max value, right? This is int max value which is there. So there might be cases that this int max is remaining and you are adding something to int max which might give you an error, right? So you want to keep your results valid. So just you see that whether everything you are doing is valid or not, because you see there are elements with only one vector with only one element, right? In that case, at least you will not get any second minimum, that will remain int max as it is. So yeah, those things you need to take care. So what you want to do is that, see, count b is nothing but b of 1 dot size minus b is the number of elements you are excluding. So what you want to do, that this count b and count c, they should also be greater than 0, right? greater than or equal to 0. So you just check that if any of this count B or count C, if count B is less than 0, or if it happens that count C is less than 0, then you are going through an invalid case. So you just simply continue with this. Do not just simply go to the next iteration. Do not bother about what is written here. Okay. So yeah, these kind of things you can be aware of, and I hope you are done with the problem. Let's try to see if it works, or we will debug it. Yeah, it works just fine. You see, we get accepted, and we try to submit it for all cases. I hope that will work too. uh, you see, it just works fine, and with 100% runtime beats. You see, it's a simple O of n solution. Okay, this loop is O of n. These all loops which you are seeing in front of you is O of n. This loop is constant time complexity. You can easily view that this is a 3 into 3 time, and everything which is happening is O of n and nothing else. Okay, so that's why you get a simple 100% runtime bit. So yeah, that's all for this video. I hope you do understand the solution. If you did not, you can definitely ask me in the comment section. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.